Here we're going to look at a couple of examples where we have a larger molecule and we want to draw all of the resonance structures for it. Let's say we want to draw all of the resonance structures for this molecule here. There's a couple ways you want to start and some guiding principles. First, draw in all lone pairs. So in this case, we have 2 lone pairs on this oxygen. On this O minus, there's 3 lone pairs to give us that oxygen's octet. The next thing you want to do is start at the charge if you have a charge. So that means I'm going to start on this O minus. If you don't have a charge, then the next thing I would do is start at a lone pair and then at a pi bond. And then finally, as you're doing this, focus only on 2 or 3 atoms at a time. So in this example, if I start at this oxygen, what you want to do is see if you can find a 2 or 3 atom system, one of those resonance systems we've talked about. So we'll include this oxygen, and that's next to this pi bond. So that's where I'm going to start. And for my first resonance structure, I'm not going to mess with anything other than what's highlighted in green there. So from here, this is an allylic anion or a lone pair next to a pi bond, however you want to look at it. And what we can do is take this lone pair, move it to here to form the pi bond, then we push this pi bond onto the neighboring carbon. Don't push the pi bond onto this carbon. This carbon's already getting electrons. We're pushing the pi bond away from that carbon onto the other neighbor. So now when we draw the next resonance structure, everything else should stay the same other than what's highlighted in green. So we have our new pi bond here. We still have 2 lone pairs on this oxygen, 2 lone pairs on this oxygen. I have a new lone pair right here. Let's put that in black. And that carbon now has a negative charge. Now, just like life, look forward, not backwards. So what you want to do is don't look back at where you've been, look forward to where you can go. So now we have this lone pair with a charge next to this pi bond. That's a new 3-atom system. So we can take this lone pair, I'll move it to here to form a double bond, and push that double bond onto this carbon as a lone pair. Everything else stays the same. Here's my new double bond, new lone pair. We have that. All right, so now, once again, start at this charge, and I can find another 3-atom system right here. So that's where I'm going to work here. Move this pi or lone pair to here, and push the pi bond up onto the oxygen as a 3rd lone pair. So here's our final resonance structure. I'm not going to worry about color coding it at this point. There's our new double bond. And the O has 3 lone pairs and a negative charge. With rings, it's conventional to draw the double bond on the inside instead of the outside of the ring. It's not a big issue either way. It just looks better when it's on the inside. All right, here's our next example. Again, start by drawing in lone pairs. There's a lone pair on the nitrogen. From here, then we want to start where we have a charge. And we have a charge here, so we can start right here. Now see if you can identify a 2 or 3 atom system. Including this carbon, we have an allylic carbocation. So what we can do, I'll highlight that in red. We can move this pi bond over to here. The pi bond is right here now. That leaves a void on this carbon, so we have a positive charge there. And we still have the lone pair right here. Now, looking at what we have next, we have a 2 atom system. Positive charge next to a lone pair. So what we do from here, use this lone pair, share it down into the bond to make a pi bond. Again, keep all of your sigma bonds exactly where they were. You never move sigma bonds. There's that pi bond. Here's our new pi bond to the nitrogen. 4 bonds on a nitrogen. It has a positive charge. So we have, for this, 3 resonance structures, and the electrons happen to be delocalized over 1, 2, 3, 4 atoms.